Hello, we have to calculate the voltage across AB in the network shown below using the Kirchhoff law. So we have to calculate the voltage across AB. Calculate the voltage across AB in the network shown below using the Kirchhoff law. So network is given to you, and we have to find the voltage across this AB. What is the voltage across this AB? We'll simplify it a little bit. This example we can write like this. I can draw the above circuit like this also. Okay. Now we have to solve this using the Kirchhoff's voltage law. So let us consider the three loops are there, and the loops current is, suppose this is I1 and this is I2 and this is I3. So three loops are there, and we'll consider the three loops. And now we will apply the Kirchhoff's voltage law to these three loops, and we will draw the equations. Now first we'll apply KVL to first loop, that is this loop. So we are going from this to this direction. So 10 is equal to this 6 into this I1 minus I2 will come here. This is 2 into this I1 minus I3, and again we'll go here. It is a 2 into I1. Okay, so these equations we have got. We will solve this equation further. If you solve this, we'll get 6I1 minus 6I2 plus 2I1 minus 2I3 plus 2I1. So we'll get here, it is a 8 and 10 I1 minus 6 I2 minus 2 I3. This is your equation number 1 after applying the KVL to the first loop. Now we'll apply the KVL to the second loop. Apply KVL to second loop. Second loop means this loop. This loop I2, the current which is flowing in I2. So we'll apply the KVL to this second loop and we'll write the equation. So there is no voltage source in this loop. There is no voltage source in this loop. So we can write here 0 is equal to this 2 ohm resistor 2 into this I2 first it is 2 into I2 plus 5 into I2 minus I3 plus 6 into I2 minus I1. If you solve this, it is a 2I2 plus 5I2 minus 5I3 plus 6I2 minus 6I1 If you solve this in terms of I1, I2, so you will get 6 minus 6 I1 and I2. I2 is 13 I2 and I3 is minus 5 I3. This is equation number 2. Now we'll apply the KVL to the third loop. Apply KVL to third loop, the loop which is containing I3. The loop which is containing this I3. So we'll apply the KVL to this loop, which is a loop I3 current is showing. So if we apply the KVL to the third loop, we'll get there is no voltage source in this loop. So 0 is equal to 5 into I3 minus I2 plus 6 I3 plus 2 into I3 minus I1. And if you solve this, you will get 5 I3 minus 5 I2 plus 6 I3 plus 2 I3 minus 2 I1. And what is I1? Minus 2 I1. I2 is here minus 5 I2 and I3 is here plus 13 I3, and this is equation number 3. Now we have to find the voltage across this network. We have to find the voltage across this network. So what is the current flowing through this? This current is coming I3 here. Sorry, I2 is coming and I2 is flowing like this. And this I3 is flowing here. I3 is flowing from top to bottom, and this I2 is flowing from bottom to top. So therefore, what is the current flowing through the I2? IAB is equal to, this is a I2 minus I3. What is the current flowing through this IAB? It is this current and this current. So let us consider this current is positive. So therefore I2 minus I3, this is coming downwards. Or we can also consider I3 minus I2. So for that we have to now find I2 and I3. So how we can find the I2 and I3? So we have to write this into the this equation in the matrix form, and we can find the, or we can solve these three equations and we can find this I2 and I3. But this is the simplest method which we can use for solving this. So this is where to write the values of, this is a 10 minus 6 minus 2, this is a minus 6 13 minus 5 minus 2 minus 5 13, and this is I1 I2 I3, and voltages are there 10 0 and 1. Okay, now as we have to find the I2 and I3, because we are interested to find the voltage across or the current flowing through the A and B, so that we can find the voltage across AB. So current flowing through A and B is I2 and I3, difference of I2 and I3. Therefore we have to find I2 here. I2 can be found, I2 can be found by this 10 minus 6 minus 2. So I2 have to find, therefore replace this second column by this, because we have to find I2, and remaining will be same as it is, divided by del, that is a determinant. Determinant is the same matrix. That matrix is my 10 minus 6 minus 2 minus 6 13 minus 5 minus 2 minus 5 13. So these values we have to find. This is nothing but, this value is a determinant del. So del value we have to find out first. If you were to find the del is equal to We have to find del, that is a 10 into this 13 into 13, 169 minus this 25 plus 6 into minus 17, 8 minus 10 minus 2 into 30 plus 26. If you solve this, we get here 800. So we can write here 800 here, and we have to also find this value, upper matrix. We have to find the upper matrix. Upper matrix is again, if you find, we'll directly get here upper matrix, value of the upper matrix. What is the upper matrix? See, this 10 into product of this, so it is 0. 10 into minus 10 into, because this is a middle term, minus 10 into this is minus 78, and this is a minus minus plus again minus 10. So what we'll get here, it is a 880 divided by 800. This is coming equal to 1.1 ampere. So I2 is equal to 1.1 ampere. Now we have to find I3. Similarly, we can find I3. I3 can be found from this equation. I3 is equal to, we have to just put the values, 10 minus 6 minus 2 minus 6, 13 minus 5. So we have to find I3. Just replace this column by this 10, 0, 0, and here it is a determinant del. We already calculated this determinant del. So we have to find this, and we can find this this into 10 into product of this, it is 0, minus 6 into product of this, it is also 0. So finally it is there 10 into this minus minus plus 30 minus minus again plus divided by what is value of del, it is 800. So this is coming equal to 560 divided by 800, and this is coming equal to 0.7 ampere. So we have got now I2, we have got I3, we have got I2, we have got it is a 1.1 ampere, and I3 we have got. So what is the current flowing through AB? It is a I2 minus I3. I2 is 1.1 minus 0.7, so it is a 0.4 ampere, and therefore we have to find the voltage across AB. So voltage across AB is nothing but the current flowing through AB into the resistance of that branch. So current flowing is 0.4 into resistance of that branch is 5. So it is a 2.04. So what is the voltage across AB? It is a 2 volt. So this is how we can find the voltage across any branch by using the Kirchhoff's voltage or Kirchhoff's law. It may be the Kirchhoff voltage law, Kirchhoff's current law, depending upon which one is suitable for the simplification. Thanks you very much for watching this video.